Okay. I'm going to give you a brief introduction to the degree project, which is an open source SDI framework. And I'm going to start with an outline of the project, then going to tell you something of the implementation of OGC standards in there, and then pay some attention to the Inspire implementation with degree before closing with an outlook and a summary. So the degree framework is providing building blocks to build up spatial data infrastructures, and it had the main development goals in mind to be a simple framework providing as many building blocks as needed for a comprehensive SDI, while adhering OGC and ISO standards as closely as possible. And it's available under an open source license, the LGPL, so it's free to use to everybody and also free to be integrated into other applications. And it today forms the base technology for quite some geoportals and spatial data infrastructures around. For instance, the Inspire provinces in the Netherlands provide view and download services based on degree, and the productive version of the geoportal will be based in large parts on degree as well. So, who's behind this project? It started in 2000 as a joint project between the University of Bonn and Lathlon, which was actually founded out of the university as well. So, since then, it has been evolved around quite a rather big community by now, and it became an official OSGeo project. So the Open Source Geospatial Foundation has recognized it as an official project. And the community is built around the website, degree.org, and we provide many tools for developers and users to get involved, like an SVN for the code base, mailing lists, a bug tracker, an artifactory where recent builds are provided for download. We have the Degree Day, which is a community conference, which happens every 2 years. And quite recently, we started to develop or write a handbook, and there's more. So, Yanni just mentioned some advantages of open source software for administration. So, one might ask, what is the benefit for a company like ours to actually work with open source software? So, besides ours, there's some more companies building business around degree by now, and the idea is to provide the base software for free as open source, and then offer customization and consultancies and tailoring around this. Well, these developments that are funded go back into the open source project, so it's actually a benefit for others as well. This gives you an overview of the different components that degree consists of. So the main block and the most recognized one are the web services, like map service, a feature service, processing service, coverage and catalog services. There's a web application that comes with this. It's called Degree Portal. A desktop application, Degree Desktop, security component to secure these services. And we also have a set of tools, for instance, for bulk import of metadata and validation. Degree has a long tradition in implementing OGC standards, and it's the reference implementation for those 3 services listed here. It's certified compliant to 2 more, and we're actually implementing, for instance, the CSW as well. And Lathlon is quite involved in the OGC as well. Since 2000, we're a principal member, so we can take influence on the process of the standardization quite heavily. And we are currently in the OWS 9 testbed developing the reference implementation for the Web Feature Service 2.0 and the Web Map Tile Service 1.0.0. Now, looking at Inspire, as you're all aware of, the local data of all the member states needs to be transformed and provided in this Inspire compliant way. So this is mostly boiling down to providing web services of different kinds to provide access. And the main challenges around this are the provision of these Inspire compliant services, the discovery service, view services, download services, which are all based on OGC standards to begin with, but then have their Inspire specific extensions. So Inspire defines quite complex data models, and these data models need to be, or the national data needs to be provided in these data models, and this might lead to transformation. And while the discovery services and the view services are quite advanced by now, while there are still many problems regarding quality, etc., but the next step to take are the download services. So there has been this SDIN best practice network, which provided access to Annex 1 data, and a lot of experiences from this were quite helpful in developing, I guess, the final version of the download service specification, and also for the implementers this was a valuable experience. The complexity of this Inspire model created quite some problems, and also with the implementation of WFS this was not always easy. So the degree download services was influenced by this experience quite heavily, as we started to develop the support for complex schema handling, for instance Inspire data, or also other schemas which are supported by now out of the box by degree. So you can configure a degree download service only based on these unmodified schemas, and degree does the rest for the configuration. So this boils down to, if you have national data, you extract, load, transform and load it to valid GML, and you can just put it into degree and it will be loaded into the feature stores. So the download service is based on what we call a feature store. That's an abstraction layer which acts as an access point for features. These features can be from S3 shapefiles or PostGIS or other databases, or this could be GML instance documents as well. So the feature store has a purpose to provide features to a download service, but also for the layers of a WMS. And if you look at this example of an SQL feature store, so a feature store that connects to a database to extract those features, degree can be configured just in this table-driven mode, as you see up here. So what happens is that degree connects to a database and creates the feature types from the columns of this database. This is nice, but if you have your GML application schema and you still need to create a database to be able to load that data into it, it would be nice if you don't have to do this task of setting up the database yourself. So what you can do with degree is use this GML schema-driven mode, and it will take the schema and create your database tables as well as the configuration of the download service for you. So it takes this complex model and maps it to a relational database table, or several tables actually. It also supports a blob mode where you can still keep the GML as a blob instance and then exit it via expressions. And the outcome of that is the WFS, where you can access your single feature instances. So this tailors it all together. You have your data stores, several database backends where you can load your Inspire data sets in, and the WFS and WMS directly go onto these feature stores. So another nice feature of this is that it supports WFS transactions, so you can actually change your data and you have it reflected directly in your WMS layers. So we can quickly go through the feature highlights regarding the degree services. They support the Inspire download service specification, the WFS, OGC specifications with transactions, several GML formats as input and output, the ISO 19107 feature model, and several other features like on-the-fly coordinate transformation, And it's based on a streaming architecture, which makes it very well scalable. So you can have very, very large GML documents working on it. For the view service, it supports the Inspire view service specification. Thomas was actually mentioning this issue with multilinguality, and he's correct when he says that it is supporting the parameter, so it's actually implementing the guidelines, but it's not supporting multilingual content at the moment. This is mainly not so much a technical issue, but this shows a bit the nature of an open source project, because it's mainly driven by requirements and needs from a project. So if there's nobody out there who's actually wanting to do this, there's not really a need for doing it for us. So it needs to be funded in some way. Well, besides that, the WMS 111 and 1330 standards are supported. It renders complex data sets. It has sophisticated styling features, and is also based on the streaming architecture. And the discovery service we offer as well supports the Inspire specification. It's fully transactional, and it has a similar concept as this feature store configuration that I introduced, which actually leads or enables you to provide new application profiles and backends quite easily. To sum it up, Inspire is actually a main driver for the degree project development, as a lot of administrations come up with new requirements that go into the degree project. And it's quite a perfect match. It handles comprehensive, or it offers comprehensive support of complex application schemas. It has this tight integration of the view and the download service. It's very scalable and performant. And it's open source, so it shares the innovation to others. So I encourage you to try it and to support it, and also to sponsor it if you have requirements that are not yet implemented. You're very welcome to contribute to this project as well. So what are we doing at the moment? It's a WFS 2.0 reference implementation, which should be finished by the end of the year. And it's actually, it's quite far already in the development, so you might want to try it out and use it already. Same for the WMTS. And then something that was neglected more or less in the past was the documentation. So the community started to develop this handbook, which is also in the repository and built every day. So documentation is quite an important topic at the moment. And if you get frustrated with degree in the past, you might want to try it out again. So this year we also have our dedicated project conference in November in Bonn, and contributions are still welcome. Thank you very much for your attention.